Last year at the Gradle Summit, we presented Gradle Enterprise 1.0. And this year, we can show you Gradle Enterprise 2017.4. A very exciting and big release. We released it 2 days ago. So if you're already using Gradle Enterprise, go to the admin console, hit that upgrade button, and enjoy. Maybe also really read the upgrade notes first, but pretty much ready to go. So what is Gradle Enterprise? Gradle Enterprise is a easy to install, easy to use software application that is hosted within the boundaries of your company, so on premises. And it provides a set of services on top of the Gradle build tool. The Gradle build tool that you already know. And the services we currently offer are the build cache and build scans. Right, then we're going to take a look at both of them. And we're going to look at scenarios, how they help you solve current problems or challenges that you face when you work with a build system, and how you can overcome them. So let's start with build scans. What are build scans? And I'm going to start with a little demo instead of giving you a theoretical explanation. All right, so I have a little project here. Which is called the Gradle Build Scan Quickstart project. It's on GitHub, it's open source, and it can be used to just demonstrate quickly how you use it. So I'm going to run a build. And I'm passing along dash scan option. That's an option understood by Gradle, and it will capture data while the build is running and publishing to a remote server that I configured. And I can now go to that URL and see that build scan. And now I'm going to give you a very quick tour what you see on that build scan. Not in depth, we'll look at more concrete use cases afterwards. So what you see is the data that we capture basically, and that we can then lift to something that you can reason about. So we have a summary section telling you what versions are being used here. And then we also give you the console output. So you see the full console output if you need to consult it. We have a timeline where you see everything around task execution. And of course, as a developer, that's very interesting for you to see what was executed, what wasn't, how long did it take, how are things run in parallel, and so on. We have a performance section where that's interesting if you want to improve the build or if you want to understand where is time spent from task execution, project configuration, how about the daemon, how about the build cache, that's all covered in here. We provide information about the tests that are run, the longest ones, the failed ones, their outputs, you can search, and so on. Information about the project structure, which can be very deep or very wide. In this case, it's very simple. It's a single project. We give you all the dependencies information for that build across all configurations of all projects with version numbers. We show you if there was a conflict resolution happening, and so on. We provide information on plugins, what plugins were applied, what versions, and so on. We also have, so this is basically what happened in the build, but we also capture information about the environment, because it's very important when you want to reproduce what happened to know what the environment was. So here you see all the switches that were enabled and were not enabled, and we provide you information about the infrastructure, where you can see in which environment the build was run. Now, when I ran that build, I used that dash scan option. If you forget it, you won't have a scan. Right? And what you really want to have is that every scan or every build you run creates a scan that is published. Because if you capture all builds, local ones, remote ones, and you collect them in one place, then you can see trends, you can see differences, you can see fluctuations. All this is possible if you capture them all. So what we can do is we can go and just say publish always in our configuration of the build scan plugin. Go back, run it, and it will still create a build scan. And that's really what you want to do. Just create always a build scan. Right. So far we've seen the scan, but there's more context. There's the context of all the build scans, and that's where you can go to the build scan list, where you see all the builds. And there you can then sort, you can filter to find those builds that you're interested. So let's say I want to only find the builds of a given user. I want to only see those of that user that failed, and so on. That's the things you can reason about. All right. So if we come to a more formal definition of what a build scan is, where's the presentation? Sorry, not using my own laptop. That doesn't feel very comfortable. Yeah, so what is a build scan? A build scan captures data about a single build, right? And it makes that data available via permanent shareable link. Right? And what we capture is data about what happened in the build, as well as data about the environment that the build was run in. And with that, let's take a look at the build cache before we look at concrete problems.
Thanks, Etienne. So as we mentioned in the keynotes, Gradle Enterprise also ships with a build cache backend implementation. This is something that we started in our release before this one, 2017.3, and we've improved it in 2017.4, which was our release earlier this week. So build cache is all about letting you do more by building less, reusing what you've already built. So it's a really, as Hans pointed out, a key part of the performance story. Some of the stories that we have and some of the evidence of the performance improvements are really incredible that you get here. In a lot of cases, just by turning it on, doing no extra work. So what I have here is a build that for those of you who didn't see the demo earlier, run some tasks, take some time. Enabling the build cache is as simple as running with -- build cache. There are ways to turn this on always. You can have a look at the Gradle user manual, describes that. And now, my cache isn't warm. It's complaining that the cache I'm pointing to isn't there. It's because we're going to make it there in a second. That's not what I want. Yes. Okay. So let's just prove that this works very quickly and turn the local cache on. So by default, running with this, we'll use the local cache, which is a directory stored in your Gradle user home directory. Gradle will cache things there for us. So my cache is nice and warm. Now instead of taking 5 seconds, it's happening instantly. Okay, so that's out of the box Gradle. Where the Gradle Enterprise comes into the picture is that Gradle Enterprise itself provides, let's have a look, a cache. So this is the cache admin application that's part of Gradle Enterprise, which allows you to see your different caches, and we'll explain what we mean by different caches in just a second. And this just comes out of the box as Gradle Enterprise. A HTTP cache implementation also comes with Gradle Enterprise. So if you install Gradle Enterprise, /cache of that install is a location that you can just use as a HTTP cache. So getting that going would be as simple as putting in the address of our Gradle Enterprise installation /cache. So now I've taken those cached artifacts from my local machine where only I benefit from them, and I'm going to be pushing and pulling from them on a shared machine, so all of the builds from all developers and CI machines can actually get the benefit from that. And Gradle allows you to use a local and remote cache here, so we're configuring the remote cache. So it will try the local cache. If it's not there, go to the remote cache, as you would expect. So I can just do this out of the box with Gradle Enterprise, that's fine. Now what I'd also like to show is use of a cache node. So what I've got here is a separate machine. This is another machine we provisioned on AWS. And what I would like to do is create a cache node on this machine. This machine may be more closely located with some builds that I want to enable caching for, maybe on the same machine as CI builds or something like that. There are a number of reasons why you may want to deploy multiple cache nodes. So we distribute the cache node software separately from Gradle Enterprise. It's actually usable standalone, and it's distributed as a Docker image available from Docker Hub. So the public Docker repository has this software. That means on any Docker-enabled machine, you can run the command we're about to run. It will download it and provision it for you. And just to be super clear, this step does not require Gradle Enterprise. So let's go ahead and do that. A couple of things I need to specify. This Dockerisms here. The ports I want to expose from the container out. This is all documented in our manual. Here I'm using HTTPS. So I'm going to use port 443. And I need to give it a directory to work with on my host. So which directory on my host file system do I want the cache node to use as its persistent storage? So I'm just mounting that to the data directory. This is a Linuxism, the colon Z, I won't get into that. And here's the name of our software, Gradle build cache node. So I'll go ahead and do this. And that's started up. Now the address for this guy is this. And thank you, Cloudflare, for caching that. Mm-hmm. That looks right. Something had to go wrong. So bear with me 1 second here. So do I have anything in my log? No, it's up. Okay, let's fall back here. Let me try one more time. Okay, I've got some interesting network issue there. If you just bear with me for a second. Let's just try stopping this. Nope. Does that make things any better? Turning it off and on again did not help. I've now exhausted my troubleshooting capabilities. Okay. It would have complained if that would have happened. I just want to, just a good idea. PS, no, is there anything running? Collaboration. I cannot. Okay, we might have to let that one go. So I can do the next best thing here and run it from source. Okay, this is not how you run a cache node. This is how I run a cache node. Lucky we're using a pretty fast build system to build this stuff. And we're up. That's the wrong port. This is what I wanted to see. Okay. We got there in the end. This is what I was seeing. So this is the page you get when you start up your cache node. You go to that address. And the first, what you can do is configure this to talk to Gradle Enterprise. But before I do that, I'm just going to go and change this to use that instance I just started. I don't have HTTPS enabled. So even without connecting it to Gradle Enterprise, I have a fully functioning build cache, if I get the address right. So you can go ahead and install this today and use this as a dedicated cache. Works fine, standalone. Once I connect it, I can have a, from the cache admin screen here, I can, I would go through the registration process, we've already eaten up too much time. Basically create a node, provisions a key, a secret, I configure those things on the node, they're now connected. So from this application, I can now see what's going on in terms of activity. I can change its settings regarding how much storage it's going to use, configure credentials, all those kinds of things. So that's the basics of the build cache. Etienne? Where are we here?
Thanks, Luke. All right, so what we want to go through now is just a set of problems. Some were already covered in the keynote, and others not, on how you can approach them using build scans to solve them. So common cases, you look at the console, and it just shows you stuff you're not really understanding what's going on. Right. And so like I mentioned before, we are capturing everything that is logged on in build scans, and we can make it, or it's reusable anytime in the future. We can go back and look at it. Right. The key to here, besides all the highlighting and the coloring that we have, is that we can mark certain lines and we can easily share them with them. And if you think about it, this is super valuable. How do you currently share problems with other people that are in your build? You probably take a screenshot, you mail it to them, you describe it, they get back to you like, I don't know what you're talking about, give me more details. You go back and forth 3 times until you've solved just what the problem is and the state was before even looking into the solution. And with this, it's just a link and all these questions are gone. And it's just about finding the solution to the problem. So very powerful. How do I get back to the slides? This is killing me. Okay. All right, so next problem, you have some build, it's running in your system, but it's not running on another system, or vice versa. Usually that's the worst case, right? If it's running for you, everything's fine. But if it's running on CI, but it's not running for you, then the question is, why is it not running for me when it's running on in another environment? So what we see here is we have a build, it ran successfully. We have another build, which was exactly the same thing, and we had that error that I showed before, which was this javadoc error. And so the question you have to ask yourself is, what could be different? And we have all kinds of comparisons. We have dependency comparisons, we have task inputs, we can compare custom values, infrastructure, switches. So all you can compare. And so you could just look at all of them, or maybe you already have an idea where to go, and you can go directly there to see the difference between those two. As you can see here, the 102 and the 131. Right. You can also see in the top here where there are differences at all. So you see their task inputs are totally the same, so nothing to look at. There are also some dependencies that are different. So you could take a look at that as well. Okay, some configurations were in one build but not the other. And then you can decide for yourself, well, which route you want to go first to further investigate where the problem is most likely to be. And I guess that's a scenario you've all faced. I assume it runs here, but it doesn't run there. What is the difference? Why is it not running? And we can have all kinds of reasons, and we can help expose them. And like I said before, you can do this without having to interact with like a build master or something. More independence for every developer. So you have all those build scans, and now it's you really want to look at how well does it work on CI, how well does it work locally, like do you have a lot of more local failures than remote failures or vice versa, or look at how long does the build take locally versus remotely, and that's where the tags come into play. And so how to define a tag? You can, when you run the build, you can say, I want to add some custom tags to my build scan that are then made visible when you look at the UI. And the way you do it is, we have a DSL that you add to your Gradle build, and so within the build scan closure in this case, we're making a decision whether we want to add the CI tag or the local tag. Right? What that logic is of course totally up to you, as well as what you call that tag. Right? So here we see a build that was tagged with CI. So you can know that it came from CI up here. We can also run the local build, mark it as local. Right. And then it gets interesting because we can now go to the list and we see all the builds, but now we want to discriminate between the two. So I can just have this filter here where I say I only want to see the CI builds, and now I see the CI builds. So I can see I have 86 builds, and now I have 497 if you look at the bottom right corner. Right. So you can filter by those tags. You can also do the inverse. You can say, give me all builds that don't have a certain tag. And you can do the same with custom values. You can search for custom values, key value pairs, or also only look for the key or only look for the value. Right. Okay. Source control information. You want to reproduce the state anytime in the future, or anybody else wants to reproduce it. So we need to capture some information. Maybe at some point we will do, but until then you can do it yourself. And we're definitely not going to support every VCS that is out there. So how do you do this? Again, a bit of code here. So we're just calling git directly. So we're in the Gradle build script. We have Groovy available. Really easy to just invoke a command. And then we capture those information as custom values and as custom links. Right? And conditionally, we also add the dirty tag. Right? So you see, in the end, it's just your logic in here. Adding the tag is a one line. That's not the issue. Right. How does that look? You can see here the git information. Right. What's the branch name? What's the commit ID? What were the local changes? Right. And like I said before, you can search for that. So you could search for a build with commit ID XYZ. Static code analysis, so there you have all options, whether it's PMD and Findbox or check style, or maybe even code metrics, JDepend or whatnot. It's all up to you what you want to capture. And you might already do it as part of the build, so that doesn't change. The only thing that changes is that you add something. In this case, we add a hook to the task graph, saying whenever the task that we execute is a check style task, so of check style, and it has failed, then we go and kind of scan the created report, fish out the values we need, and add them as custom values, which in the end, you see errors.each. We add a custom value for each check style violation. Right? The rest is just parsing and collecting and mangling what we need. Right, and the result you see here. You could also give those custom values different names. That's up to you. We use the same name because then you can also search for builds that have that key, which is check style issue. Right. So the key message here is you can capture anything you want, and it is displayed in build scans, and you can search for it. All right, and now Luke will cover a few more projects.
All right, thanks, Etienne. So the situation we're thinking about here is that you've just run your build, you're happy, you've checked in your changes, and then you pull the next set of changes, and you go ahead and run that, and it fails. So what you do is you get a build scan, you get some compiler error output, you've got a compiler issue here, and you see this is telling us there's a reference to a class that isn't there. And it was there before, the project previously worked, something has changed to break this now. Now, I know I've got my build scan set up, so I'm capturing some of the VCS information that we just showed. I'm capturing commit IDs and some other stuff. So the first thing I'm going to ask myself, well, what is the change here? What's the delta in the commits? So, and I also know that I just ran a build previously that worked. So what I can do here is go to the kind of time navigation section and say, well, show me the previous build scan that I ran. Let's go have a look at this. Yep, that's what I ran. That was all fine. Okay, now go ahead and compare that with what I was just looking at. So now compare it with the one that happened afterwards. And here I am at the comparison section, and it's telling me that task inputs, okay, I didn't have build cache enabled, so I don't get that. But I know that I've got the VCS information in my custom values. So here it's saying that build on the left had commit ID, blah, like the other one had a different value here. So I could then go to GitHub or whatever source repository tool I have and say, show me the difference between these two commits. What actually changed? So let's imagine I do that. I run that diff, and I see that, yes, a dependency did change. Somebody checked in a bump from version 1.0 of a given dependency to another version. But I know that dependency, and the error that I got before, if you go back here, that's not it. That's coming from another library. That isn't that dependency that was bumped. Right? So now something is off here. So that dependency, changing that dependency has caused some other flow on effect. It's a good chance that this is dependency related, this issue. So one thing I can do, I'm just opening that comparison again. I can actually compare the dependency graphs here. So what I saw in the diff that I looked at was this. This dependency changed. It went from 1.0 to 2. Right? This is new to me. This I don't understand. So this also changed, this other library. And probably by the name of this plus the package name of the class, I can probably see some relationship here. So this is a very cut down, simple example. It's kind of easy to see what's going on, made easier by the names of these things, if you probably have got it already. But in a larger graph, where it's more complex, this might be more difficult to see the relationship. So now I want to see, well, this guy wasn't an explicit change. There wasn't a change in the build script to this guy. What happened? So if I click on either of these, let's have a look in the after one. I get taken to the dependency section of the build scan for that build, and I'm now looking at the graph in the shape of a graph. So one thing I just want to point out here is that what we're seeing here is the flattened list compared. But if I go through here, I'm seeing the graph structure. Now I can see straight away what's happened is this was the thing that I saw had changed. It had a transitive dependency, which has also changed as well. So the diff in the build script wouldn't have told me that because it was a top-level dependency, but by comparing the actual resolved graphs of what happened, I can see that this brought in this unwanted change here. Okay, next one. Digging into configuration time problems. Configuration time has been up until now largely a black box. What is Gradle doing for that whole time where it's saying configuring? Right, you get some indication as it cycles through projects, but even in there, there's not a lot of information to go on. So the project configuration section of the performance section of a build scan gives us a breakdown of configuration time by project. Slowest first, so we can see we spent the most time configuring the root project, and we also had a child project that was an anomaly here. Lots of stuff happens during configuration time. Lots of code gets executed, but most of it is very fast. The pattern that we see quite often is that there is some hotspot. There's some part in the configuration that is doing something like reading a file from a network share or calling a slow network service. So what we see quite often is that these things really pop out. As soon as you can see where the time is being spent, you can go and find, okay, it's that script or it's that plugin, go and look at why it might be doing that. So if I break down each of these projects, I see the what we term code units, but really we just mean the scripts and the plugins that happen as part of that project. So as part of configuring child 7, we did two things. It had a build script, this is very common, and it also had their built-in help tasks plugin. And we can see here that running that build script, that build.gradle, took a second. So that's far too long, something's wrong there. Here's a more complex example. So here is the root project. And this is very common to see something like this in the root project because a common pattern is you have your root project build script applying plugins to all kinds of children, right, using all projects or sub-projects, that kind of thing. So I can see that playing out here, that as in an all projects loop or something like that, I applied the Java plugin to all those children. So this is about what you'd like to see, numbers like this. That's fairly reasonable in terms of time taken. And you can see sort of certain things popping out. A lot of time, there can be a kind of death by 1,000 cuts issue here with certain types of plugins just being a little bit too slow, but they get applied so many times that really starts to add up. But you can see the count of the applications and those kind of numbers in here as well. So that's really a level of granularity in configuration time that we haven't had up until now. Of course, what these things are doing is really then up to you. So what this, sort of diagnosing and fixing those problems, but what this really does is shows you where the time is going and where should I next go and look to try and optimize that. It's a really great head start on that. Yep. And I've just closed the slides, haven't I? Indeed. And we're back. All right, so the situation there was that I had some kind of indication that configuration time is a problem. I could go in there and dig into that side of things. But there are a whole class of other problems that we have. So here's a case where I have a build, and I'm just looking to do some proactive optimization of the execution time of this build. So maybe I'm just picking the latest CI build, go and look at it, look at the build scan, and I want to think, what kind of things might I be able to do to make this faster? There's a lot that can happen regarding the structure of your build and the way that it's parallelized, the way you structure your code to try and make things more efficient. And the timeline view here gives us a nice graphical representation of how task execution played out for that particular build. And our experience has been that a picture's worth 1,000 words. This has really exposed to us and the builds that we've been working on with build scans the fundamental nature of builds and what are the slow blocking tasks and what are the things that are really dominating execution time. So what we're seeing here, the reason that this particular task is highlighted is that it's dominating execution time. So the more time that a task is taking relative to the rest of them, the stronger the color here. So on a more sophisticated project, you'll see sort of gradients of colors here showing you which ones to go and look at. So effectively, the closer to green, the more time it's taking. So here we have a relatively common situation where we have a dominant task taking much longer than the others. And this is telling us a couple of things here. It's telling us what that task is. That's much slower. And it's a bit easier to see on this graph. You can see the high level of detail. Each of these blocks are discrete tasks up to a certain level, and I can see this big long task blocking here. So this is telling me that this is the slowest task. And I can also see a phenomenon here that because this task is starting late and running long, it is effectively choking the concurrency here. So I've got all this white space here where Gradle wasn't able to run things in parallel because this one long task kind of blocked the line. I can also use this in more complicated scenarios. I can use this to do some more fine-grained analysis because really there are two ways to make this faster without deeper structural changes to the build. You either find some way to make this faster, make that task do the exact same thing faster, or you try and do it sooner. Right? If I can bring this task forward, then my build is likely to complete faster. So if I wanted to do that, I don't have, right now, I don't have the ability to restructure and reorganize my build or even break this task up into smaller, more parallelizable units. I just want to run it sooner. Anybody have an idea what I would do? No takers? So the answer was change its dependencies or put it earlier on the command line. Yes, I could. Let's say for instance, right now I can't change its dependencies and I also don't want to put it earlier on the command line. I want it to happen by default. So a feature of Gradle that is probably underrepresented and underknown is the task orderings. So this is task should run after and must run after. Right? So in this case, all I need to do to my build script is say that every other task should run after this task. Right? So I can just, in a loop, say all projects, all tasks should run after this task. So that gives Gradle a hint to basically prioritize this task and run it forward. So if I now go and if I do that, this is the effect of doing that afterwards. say before here. So this took 45 seconds. You can see this happening midway through the build because it's just using Gradle's natural scheduling here to pick when to run it. But if I give it an explicit hint saying that actually you should run that fast because it's long and it's going to unblock later tasks, I say 15 seconds. So it's the same task, the same amount of work. So by reordering things and identifying the critical path and trying to make sure Gradle runs those things sooner in the build, you can improve performance there. And it would take a dedicated effort without build scans and timelines to see that. But this graph representation, having this information available for multiple builds over time, makes it so much easier and so much cheaper to do that. Okay, so we've got another case. We're just looking to make this build faster. Because you're on a roll, you fix that one, you want to do another one. Okay, so this is probably a slightly more realistic case. Lots of projects look like this, where they're just completely dominated by test time. All right, so I can see here that, well, working on anything else will be a complete waste of my time. I have to get those tests to run faster somehow. All right, so don't even bother working with anything else. And a surprisingly effective but simple method of doing this is just having a look at the tests and how long they took. So this is the test section of the build scan, and it just orders things by the slowest. So it's hard to overstate how effective this is, but just regularly going into this, picking the slowest test and making it faster will make your build incredibly faster. And there's usually so much low-hanging fruit in tests. But because we're not watching all the time for those times, especially on tests that perhaps aren't edited or run individually frequently, we can really make a huge difference to a build by just keeping those test times under control. So there's two things there. The timeline showed us straight away of where to invest our time, what was completely dominating there, and just having that test information here. Another thing that we found very useful is in the summary section of the tests, we just show the slowest tests here. And I've been surprised quite a few times looking at scans of our builds going, really that test, that's the slowest one. There's no good reason why that should be so slow. Fixing it, making it twice as fast, and then getting that benefit in our build. Etienne?
All right, so scenario, you run a task or you run a build. Some task is not up to date, even though you expect it to be up to date. Similar to what we showed in the keynote. If I go to the timeline here, I can say compile Java, why was it run? And I can see that some input property here, a source file changed. So that was the reason why this task was run. Can open another scan, also something changed, but in this case it's not a file, but other arguments that make up the input of the task. Right. And that is important to keep in mind, because often you think, okay, no files changed, so why did my task still run? But there are other things that go into the inputs of a task, like here, the compiler arguments. Right. And they are easily different between different environments. All right, so Gradle 4.0 ships with the build cache, as you've heard, and there's no reason not to use it. And when you use it, you want to make the best of it, and that's really where you need build cache. So we have, build scan. So we've worked very closely with the build cache team to provide you the most insights in what's going on, especially when things are not working as you expect them to work, right, which can be very difficult to debug without build scans. So what do you do first? If you enable the build cache, you enable build scans as well, via GE, ideally. And let's make sure we're actually using the build cache. So in the switches section, you can see all the switches of Gradle that are being active. All right, so we're good there. On the performance, in the build cache tab, we see what is configured with regard to the build cache. So you can have a local cache and you can have a remote cache. And both can be either enabled or disabled. And we see here that the local cache is enabled. We see whether we are pushing to it or just consuming from it. And we see even the location on your system, right? where it is located. We can also tell that the remote cache in this case was disabled. If it were enabled, we would see similar information. Right. We also get a build cache summary because we want to get a feeling of, okay, how much is that build cache even helping us? Are we getting any hits? If we're not getting any hits, the build cache is not good for anything. Right. And we can see here, actually very good. This is a Gradle build that we imported, a build scan from a Gradle build. There was not a single miss, meaning a task was cacheable and it tried to reuse outputs from the cache and it didn't miss outputs a single time. So it was able to leverage what's in the cache every single time. It got 788 hits. You can also see how long it took to download those artifacts and process them and reuse them, and how much data there was. And we also give you the speed. Okay. And the speed, of course, can be an interesting indication, especially when you use a remote cache, in how fast your connection with the cache is. Right. We can also see that this build didn't have to store anything in the cache because, well, everything it did, it was taking it from the cache. We then have a further, more detailed breakdown of every operation that happened with the build cache. So every hit we see, every store we see, and every miss we see here. Right. And we see that for each task that was trying to reuse or put something in the cache, we see the build cache key, which can also be helpful when debugging. And we can, of course, then also browse to that task. So I can go here, and then I see more information about that task, where it was run in the build, and all the details about it. Right? So this is all interconnected with each other as well. Okay, so that gives us a good first indication how well are we leveraging the cache, either by consuming artifacts or by producing artifacts. Okay. Now let's see a bit more in detail how much are we actually able to use the cache, but not in terms of operations, but in terms of tasks reusing our cached outputs. Okay. So again on the performance, but not on the build cache, but on the task execution, we see a breakdown of the tasks by whether they were run or whether they were not run. And if they were not run, were they up to date? So there was not even a build cache involved, or were they reusing outputs from the cache? And if they were executed, were they cacheable and just there was no output from the cache available, or were they not even cacheable at all? Right. And what we can see here is those tasks that were not run, they all took the outputs from the cache, except 2 tasks that were already up to date. The other ones were not. And from those that were executed, all of them were executed because they're not even cacheable at all. And this is, of course, the interesting thing when you want to improve the performance. You want to make those tasks, not necessarily all of them, but some of them also cacheable, because then, yeah, you improve performance by reusing outputs. Right? So, and we can navigate there. So for each section that is here, we can just say, let's go here. Okay. What we also see on this screen is a breakdown in terms of time, like where is the time spent? Right. That's what you see on the very right-hand side. Okay. So just because 50 tasks are not cacheable does not necessarily mean you have a performance problem if those 50 tasks only take 3 seconds to run. Right. So the time is all, the sum of the time is also important to keep in mind here. Right. And then we can go to the timeline when we have all those filters applied now, where we see all tasks that were either successful or they failed, so they were executed, but they were not cacheable for any reason. We can also break this down further and say, well, we're only interested in those where the task itself is not cacheable. Right? You can go here. Right. But to start with, we can just say we're interested in any reason. And then, once you're at this point, you order by execution, as we do already. And then you start with the ones that take the longest. So those are worth the most to optimize, those tasks that take the longest. Right. All right. Yes, and then we have the scenario, which I'm sure you're going to run into, is that you have unexpected cache misses. And then the question is, how do you go about that? So you have one build that puts something in the cache, and what you see is the cache key. You see that it's a store, and you see that it's stored it to the local cache. Right. You can also see a cache miss, meaning it first tried to fetch it from the cache, but it wasn't there, so it put its output into the cache. And depending on whether you have local and remote enabled, you could have more than even 2 operations. You could try in the local, not find it, go to the remote, not find it, push it, push it. Right. Okay, so we see that it put it actually in the cache with a key 71 something. And then we have a build later on, same task, trying to reuse it, but we already can see that there's a different cache key involved here. Starts with a different prefix. It couldn't find anything in the cache, so it stored it again. That's the scenario. And then we can use the comparison to find what the difference is between those two. Right. So whether the task type changed, an input property changed, the class path changed, an implementation of a do first or a do last changed, or the order changed, we're all taking that into consideration. All right. And with that, we move on to the export API.
Yeah, so that was just a selection of particular problems, particular uses of Gradle Enterprise, by no means comprehensive. One other thing we want to point out that's available is all the data that the build scans are based on is available to you. There is an API, and if you're in the keynote, you saw Sam demo some of this. This is another sample using that API. We call it the export API. Basically, all of that data is available to you via a real-time streaming API. Uses server-sent events. It's going to HTTP, JSON-based. You can connect to it, get notified of new builds, consume those builds. So here's a sample using that information to chart the failure and success rate of builds and their build duration over time. This is it's available via that sample link down the bottom there. It's some very simple JavaScript and HTML. Really quite easy to get going, but you can do whatever you like with that data. It is, after all, your data. Sam is talking tomorrow, I believe, where he's going through in more detail about how he used this at Tableau to build those dashboards that he showed in the keynote. So this is the exact raw data that we use to build scans. It's available to you to consume in real time. If you want to know more about this, check out those samples. In the Gradle manual, we have information about using this API, instructions, etc. So now we're getting going, running a bunch of builds. You can see in real time this stuff being charted and measured. So that's the export API. We could next year hopefully have time to do a whole talk dedicated to that in itself. All right, some of the things we didn't show very quickly. The whole dependency search section, so you can look across all the dependencies resolved in your entire build, search, find dynamic dependencies, etc. Explain the plugins we build, test failures. So if you have a test failure, there's a dedicated link to that failure, including all the console output and stack trace that you can share, poke around. Memory usage side of things, dependency download network activity we didn't show. Some more sophisticated uses of the searching with the scan list. Some really cool stuff you can do there. So what's next? Where are we going over the next year and more? So we're going build scans, doing more cross-build analysis. There's just a treasure trove of information in that historical store of build data, so adding more and more features that leverage that information that we have over time. More resource usage insights, more insight into how the machine's performing under the workload, with all the parallelization work we're doing, with all the processes that are forked, how are they performing, how's memory going there, how's CPU doing, etc. More and more fine-grained performance insights with configuration time and task execution time. A trend you'll see is that we're adding more and more higher-level APIs in Gradle for scheduling work and executing things. And one of the benefits of doing that is that we can instrument that and really observe what's going on and surface all that in build scans in a really cross-cutting way. Another one is having more developer-oriented feedback, so having more structured information about what tasks are doing, how they failed, etc., and being able to share that. On the build cache side of things, being able to arrange caches into a federation and distributing data across them, and particularly for more sophisticated cache topologies. One of the challenges we're seeing is that network bandwidth is really the big constraint here. So dealing smartly with the fact that I want to ship things between two caches, but I've got a limited amount of pipe to use there, so I have to be very careful about what I do ship and when. And that is, that's a big area for us. Transparent load balancing and fault tolerance. So you'll just be able to say, okay, I want to use the Gradle Enterprise caches, have Gradle Enterprise work out which cache nodes you should use and all of that, and if one's not available, choose another one, all that kind of stuff. Yes, and better, more efficient cache usage by understanding what the cost of a cache fetch is versus building it locally. So you're not spending actually more time fetching things that you could have built locally. And lots more, of course. So if you want to get started with some of the stuff that we've seen today, particularly with build scans, you can use scans.gradle.com. It's a public build scan server that we make available that you can use free of charge. You can use it in any build, push your scans to there, have a look. It doesn't have all the features of Gradle Enterprise. There's no scan list, there's no kind of comparison across builds, but you can use it to play around with scans and use it for local projects. You can install a cache node, hopefully more successfully than I did today. But I said if you have a Docker-enabled machine, you can do it right now. Install the cache node, configure your build to work with it. You can also start a trial. So if you go to the Gradle.com website, you'll see there you can get in contact with us. You can get a trial copy of Gradle Enterprise, install it, have a play with it. And don't forget, also check out the release notes for 2017.4 if you're using Enterprise already, or you want to have a bit more of a look in detail at some of the features we've added. The release notes are quite detailed about that. So thank you very much for coming. Unfortunately, we're a bit over time, so I don't have time for questions. But if you want to come talk to us about Gradle Enterprise or anything else, you'll see us all hanging around just in this section out here, typically where the food and stuff is. That's pure coincidence, I promise. All right, thank you very much for coming. Enjoy the rest of the conference.